aldol cannicerose cross cannicerose crossed aldol. So 4 options are there. Now what are the reactants in each case? Here the reactants are substrates, or the word substrate. Yes, what are the reagent or substrate in aldol condensation? So aldehydes are ketones. Are ketones having at least one alpha hydrogen. One alpha H. This is the first point. The second point is the reagent base or acid. Because acid catalyzed or base catalyzed. Now, here the intermediate is beta hydroxy. Aldehyde or ketone. Now, finally, the final product. The fourth point, final product is alpha comma beta unsaturated aldehyde or ketone. Ketone. So basically these 4 points you should know about aldol condensation. Yesterday already we have given. So if you write some examples. Over. Now, example 1. Two molecules of acetaldehyde in the presence of base or acid form CH3 CHOH CH2 CHO. Yesterday we have already given the mechanism. So mechanism part I am not looking at. This is beta hydroxy. Butyraldehyde. Called aldol. Now this gives the final product, losing water. This is alpha carbon. This is beta carbon. After the removal of water, you will get CH3CH, double bond CH-CHO. Alpha beta unsaturated aldehyde called crotonaldehyde. Similarly, example 2. Two moles of acetone now in acetaldehyde, this is alpha carbon, 3 alpha H are present. In acetone, 2 alpha carbons, 6 alpha H. So in the presence of base or acid catalyzed or base catalyzed, you will get a beta hydroxy derivative. CH2 COCH3. So it is 1, 2, 3, 4. 4 hydroxy, 4 methyl, pent 2 one. This loses a molecule of water. Double bond CH. So this is alpha carbon, this is beta carbon. Between alpha and beta there is a double bond. Double bond is called unsaturation. Double bond or triple bond is called unsaturation. That's why the product is a alpha beta unsaturated compound. So 1, 2, 3, 4. 4 methyl, pent, 3 in, 2 on. So if you go to the first slide, previous one, here 2 molecules of same substance are involved in condensation. Thus it is called normal aldol condensation. If different are involved, it is called crossed. So I am writing here first point, if different molecules or reactants are involved, it is called crossed aldol condensation. Four different products are formed. Reagent and reagent is same, base or acid. Product is also same. Everything is same. So to understand this last column, we go for a real example by using different molecules, how the aldol condensation occurs. Ready? So here I am taking a test tube in which I have taken some acetaldehyde, some acetone, and also added a base like barium hydroxide, a dilute strong base we use, and slightly warm the mixture. Now, see the probabilities. The OH minus can remove alpha hydrogen from aldehyde. So this is the first probability. So CH3, CH double bond O. So the base will remove one of the alpha H. So when alpha H is removed by base, you will get a carbanion. Or nucleophile. So immediately student asks, why to remove this alpha hydrogen? This also can be removed from acetone also. So second possibility, from acetone also it can remove one of the alpha hydrogen. So the OH minus will remove the H plus. So you will get another carbanion. Because two different molecules, obviously two different carbanions are formed by the base. Once carbanion is formed, it will attack its own molecule, the second molecule of or it can attack the different molecule also. So the carbanion can attack the second molecule of acetaldehyde, or the carbanion can attack the second molecule of acetone. So this gives two products. Similarly, the second carbanion can attack its own molecule, that is acetone molecule. Or this carbanion can attack the acetaldehyde molecule. So two products here, 1, 2, 3, 4. So after this attack, a new carbon-carbon bond is formed. Condensation essentially involves a new carbon-carbon bond. Two molecules are connecting with each other. After that, protonation, O minus, take the proton. After that, removal of water. The remaining thing you know. So I am not writing the products. This finally it become too much spoon feeding. So you write the products. Later, not now. If you have any doubt while writing the products in doubt session, you can ask. Okay, this is over. This is what? Crossed aldol. Crossed aldol. Now we are going for Cannizzaro. Here the reactant or substrate aldehydes without alpha hydrogen. Without alpha H. Reagent is base. Two molecules are involved. In which one undergoes oxidation, resulting carboxylic acid, the other undergo reduction Giving an alcohol. If two different molecules are involved, we call it as crossed canism. So first we will see the Cannizzaro reaction. First we will go for Cannizzaro, then we will see crossed Cannizzaro. So actually NEET paper 180 bits, 180 MCQs, 180 minutes. Correct? So each question carries only 1 minute. On an average, you have to spend only 1 minute per question with accuracy because negative marking is there. So some of the tests conducted here, yesterday some students brought some problems, some questions which are too lengthy, time taking. Actually, the paper setter, I already informed our Dr. Varun Murthy. So starting from the first paper, many questions are there, minimum 6 to 8 questions in each paper, either out of syllabus, like environmental chemistry, solid state, surface chemistry, gaseous state, states of matter, chemistry in everyday life. So every paper. So that questions, actually you have to remove those questions and add full marks and count your total. Whatever the marks secured by you are not the real marks. Every paper you round off the out of syllabus, assume that the questions are in the syllabus you answered correctly. Add the marks, then you will get more confidence. Here the question of confidence is more important. When we are approaching nearer to the exam date, students should be more and more confident. Already I informed him once. I don't want to inform in a repeated number of ways because he is already experienced. He should give instructions to the paper setters. He might have arranged some external agency to give paper. So all the India's leading institutes for NEET like Akash, LN, Chaitanya, Narayana, these are 4 giants actually. Their student base is more than 2 lakhs, 3 lakhs students are there in each institute, spread over the entire country. So, they are instructing the lecturers not to give any point outside the NCERT book. They are very rigid. One is paper setter. If I set the paper, one of my colleague will refer the paper and object 10th question or 20th question are out of syllabus. then I have to remove and replace with new questions. So before giving the paper to the students, they take that much precaution. So nothing to worry. So those questions which take too much time, 5-10 minutes, suppose after spending 10 minutes you solved the problem and say, oh yes, I solved the problem. But you lost 10 minutes, you lost 10 easy questions which you cannot answer. Because yesterday I solved a problem to that person. Molecular weights are given, equivalents are given. I solved in one way, and Dr. Tony solved in a different way. We got both same answer. There's a different issue, but that takes too much time. So in UPSC civil service examination, India's highest prestigious exam, which will give you IAS, IPS, IRS, such positions. So in the instructions the UPSC gives, the question paper is set in such a manner that no student makes any special study in any special subject. Second point they mention, the paper is of in general in nature to assess the student's overall understanding and knowledge in the contemporary India and also in the world affairs. Third point they mention, no student is expected to answer all the questions. Some questions are tricky and time taking. They mention clearly. So don't spend too much time on them. Immediately switch over to the next question. So what you have to do in your NEET exam also, generally commonly adopted pattern is chemistry, biology, physics, that is the order they do, or biology, chemistry, physics. Physics will be the last. Okay? Okay, in chemistry you answered out of 45, 30 questions. You directly know. You perfectly know the answers. You blackened the circles. Over. Then you attempted the biology. You also did well. Then you entered into physics. Generally what we advise, or the physics teachers advise, without numericals try to answer any direct questions, conceptual based questions, theoretical questions. Okay, let us say you answered 10 or 15 only out of 45. Because physics is the toughest for many students across the country. So after doing all this exercise, then come back to first paper, try to do some things, then next go to the biology paper, next physics paper. This is the order you have to follow. Because the toughest paper you don't try to answer first, you will spend unknowingly more time. So this is one thing. So you have to be very careful. You should not spend too much time on a particular question. Avoid that question, sir. But they have no time. They have not even looked at it. You have to look at each paper fully, 45 questions. The easiest questions should be answered first in all the 4 papers, because there is no individual cutoff. Overall marking only. Suppose you should secure minimum this much marks in physics, this much marks in chemistry, no individual cutoff. Individual cutoff is there in JEE exam. That is only 23 questions. Sometimes they give 23, sometimes 21. They don't follow any rule also. So 3 papers, 3 into 21 or 3 into 23. So they are only answering 69 or 70 questions in a 3-hour time. You are answering 180. Same time. JEE mains is also 3 hours. Yours is also 3 hours. There the relative toughness of the question is more, so student can spend more time to solve that. Do you understand this point? So based on this, be careful. Next time onwards, you inform your who are correcting the papers. These are the out of syllabus questions. You add marks, then give the total. Okay? Okay, now Canizaro will go for. So this is formaldehyde. Oh, maybe this is not charged. So formaldehyde is the one without alpha hydrogen. Write that. Formaldehyde. Second one, you write the example C6H5 CH double bond O, benzaldehyde. That is second example. Third one, trimethyl acetaldehyde. Trimethyl acetaldehyde. CH3 thrice CCHO. So these three examples so formaldehyde, benzaldehyde, where is our engineer? This is not charged. So these are the three aldehydes. Aldehydes without alpha H. Without alpha hydrogen. This is the requirement for Canizaro. Now if you take formaldehyde as an example, so CH2 double bond O, it reacts with the base OH minus. So the base directly attacks the carbonyl carbon. OH, O minus. This is step 1. So in second step, the O minus goes back. When it goes back, one of the hydrogen along with the bonded pair goes to the second molecule of formaldehyde. This is called hydride ion transfer, H minus transfer. And this is the slowest step, and is called the RDS, rate determining step. So this gives CH double bond O, OH plus CH3 O minus. Now this acid will give a proton to the O minus, resulting the formate ion plus methyl alcohol. This is mechanism actually. 3 steps. So if you use formaldehyde as our starting material, what is the first step? The base attacks, resulting this compound. The O minus goes back, hydride ion shift, slowest step called rate determining step. So that will transfer a proton, resulting formate ion. Plus methyl alcohol. Suppose if the base used is NaOH, you will get sodium formate. Formate ion place, you will get a salt. What is the name of the salt? Sodium formate. Now we take benzaldehyde. Benzaldehyde I will do very simple job. I will remove this H and write C6H5. So this is benzaldehyde. So my job is C6H5. Here also everything is, the entire mechanism is same. C6H5 again C6H5. So C6H5 COOH, benzoic acid, and this is benzyl alcohol. So final product is sodium benzoate plus benzyl alcohol. So after observing the two reactions, we can conclude. So number one, conclusion number one. In Cannizzaro reaction, two molecules of aldehyde are involved. Aldehyde without alpha H are involved, and they undergo disproportionation. That is, one molecule undergoes oxidation and the other molecule undergoes reduction. One molecule undergoes oxidation, the other molecule undergoes reduction. Now, if two different molecules are involved in Cannizzaro, we will call it as crossed Cannizzaro. Example, formaldehyde plus benzaldehyde in the presence of base. So formaldehyde is attacked by the base, resulting this one. Now this molecule hydride transfer occurs. To the second molecule, H minus transfer. H minus transfer is called RDS, rate determining step. So this gives the formic acid plus O minus. Finally, H plus is transferred here, formate ion plus benzyl alcohol. Now you may ask me a doubt. When two molecules are available for the OH minus 2 attack, why I choose Only the base is attacking formaldehyde. Why not the first step? Why it is attacking formaldehyde? Benzaldehyde is also available. So then the reason is, in benzaldehyde, to attack the base, the carbon should carry sufficient positive charge. But in benzaldehyde, when the pi bond shifts, the ring pi bond will come to this place. It is called pi-pi conjugation. Because of pi-pi conjugation, less positive charge is present on carbonyl carbon. This is having more positive charge. This is having less positive charge. So that's why it preferentially attacks formaldehyde. This is all about Cannizzaro, crossed Cannizzaro. Now, yesterday one student also asked this point. This is called glyoxal, which you can also write as CH double bond O. Ethane 1,2 diol. What is the IUPAC name? Ethane 1,2 diol, not ol, diol. That is the IUPAC name. What is the common name? Glyoxal. Now, here no alpha H. What is the alpha H? Functional group adjacent carbon should contain hydrogens. Here both are functional groups. There is no alpha carbon, no alpha H. So that's why it reacts with base. It reacts with base. Now, the base can attack any one of the carbon. So this becomes OH, O minus, CH double bond. So in Cannizzaro reaction, after attacking the base, what is the next step? Hydride ion transfer. So the negative charge of oxygen comes back. The hydride ion should transfer to the second aldehyde group. Second aldehyde group is present within the molecule. So it is intramolecular Cannizzaro reaction. So earlier the H is transferred to the other molecule. Here the other aldehyde group is also present. H won't look for other. It will attack the same aldehyde group of the same molecule. So this gives COOH. This becomes CH2 O minus, because one H is transferred. It is called H minus transfer. H minus transfer. called hydride ion transfer. Now finally, the H plus from COOH group, acid group, give the H plus to this. So this becomes COO minus. This becomes CH2OH. So in Cannizzaro reaction, one part become CH2OH, the other part become COO minus. So one part is oxidized, the other part is reduced. This is internal Cannizzaro reaction or intramolecular Cannizzaro reaction. So this is all about 107 question. So 108th question, question number 108. This we already discussed in the basics of organic chemistry. It is there in your notes. In your classroom notes it is there. So but anyhow just I want to recollect a brief idea. Chromatography is divided into two types: adsorption chromatography and partition chromatography. Adsorption is again divided into column chromatography very good. The other is TLC, thin layer chromatography. Partition is paper chromatography. So they asked the same question. Paper chromatography is an example of partition chromatography. So this is a memory recall question. So you have to study that fundamental so that you can easily answer. An increase in the concentration of reactants of a reaction leads to change in. So activation energy for a particular reaction is always constant. So whenever reactants are converted into products, this is progress of reaction. So progress of reaction versus energy. So let us say these reactants, this is products. So reactants are already having certain energy, but that energy is not sufficient for them to transform into products. So they must reach a particular energy barrier. So the energy on the top of the energy barrier is called threshold energy. Already reactants must gain some extra energy to reach the threshold energy. This is called energy of activation, EA. The difference between the energy of reactants and products, this is called heat of reaction. Actually, this is an exothermic reaction. Energy profile diagram for exothermic reaction. Because reactants are in high energy, products are in a lower energy. The difference between the reactants energy, products energy is called heat of reaction. That is called delta H, which is negative. So whenever reactants, any reaction, when they want to convert into products, they must reach a particular height. That height is called energy barrier. So the energy corresponding to the energy barrier or the peak of the graph is called threshold energy. The additional energy the reactants acquire to reach that height is called activation energy. The difference between the energy of reactants and products is called heat of reaction. Suppose if you want to write the same for endothermic reaction, the graph will be like this. This is reactants. This is products. This is energy. So here when compared to reactants, products are in high energy state. So this difference, delta H, is positive. So whenever products are in high energy, reactants are in low energy, it is endothermic reaction. So this is energy profile diagram for endothermic reaction. This is again threshold energy. This is called energy of activation. Now, so whenever the concentration of reactants are increased, the activation energy does not change. So first option is wrong. Heat of reaction also won't change. This is also constant for a particular reaction. Threshold energy, energy barrier won't change. But the number of collisions between the reactant molecules will increase. So number of collisions per unit volume per unit time is called collision frequency. So why with increase in concentration, the rate of reaction increases? Due to increase in collision frequency. What is collision frequency? The number of collisions per unit volume per unit time or in a unit time. So that is called collision frequency. So option D is correct. Next question. Firat. Correct. Next. 111 is out of syllabus. Metallurgy. Tertiary butyl carbocation this is tertiary butyl carbocation. It is very stable because of two reasons. Stability is explained by number one, hyperconjugation. Number two, the plus I effect of 3 methyl groups 3 CH3 groups. What is hyperconjugation? It is called sigma p overlap. One of the sigma bond overlap with vacant p orbital. Sigma p overlap is called hyperconjugation. Is called hyperconjugation. So stability of carbocation is explained only on two factors. Here one factor is given in the last option. Next again chemistry in everyday life, 113 out of syllabus. That is cetyl trimethyl ammonium bromide is a cationic detergent. Elimination of reaction of 2-bromopentane to form pent-2-ene is very good. This is a good question, actually within the syllabus. So 2-bromopentane here the halogen containing carbon is called alpha carbon. The adjacent carbon is beta carbon. This is also beta carbon. Here 3 beta hydrogens are available. This carbon has 2 beta hydrogens. When the base comes, like OH minus or NH2 minus, the base want to take away one of the beta hydrogen in the form of H plus. OH minus wants, my dear H, you come as H plus. Then it says, okay, I will give my bond pair to C and C, and bromine will be eliminated. So this beta elimination, this is called beta elimination. This results in double bond CH, CH3. You will get 1, 2, 3, 2 bromo, pentane or butane they asked. 2 bromo pentane, okay. So 1, 2, 3, 4, 5. Okay, add one more. So we get a 2 pentene. Now there is one more option. The base can attack this beta hydrogen also. Base has no partiality because 2 beta hydrogens are available, one on the right side of the bromine, one on the left side of the bromine of the leaving group. So if this H is removed, you will get a double bond here and you will get 1 pentene. 1 pentene. So this is also beta elimination. So who are finally eliminated? One H and one Br. This H is eliminated, this Br is eliminated. So minus HBr. Here also minus HBr. It is called a dehydrohalogenation because both hydrogen and halogen are simultaneously, means at a time they are removed. What this process is called? Dehydrohalogenation. Actually, a Russian scientist called Sergeyev or some books, Russian names are difficult to pronounce. It is also called Zaitsev. Both are same person. He observed the dehydrohalogenation of alkyl halides with a number of examples and found that in this beta elimination, in the dehydrohalogenation, always a more substituted alkene or the doubly bonded carbons containing more number of alkyl groups as the major product. Here the double bonded carbons are having one alkyl group here, one alkyl group here. It is forming more than 80%. This forming only 20%. Because here double bonded carbons are these, only one side is alkyl group. Here both sides alkyl groups. So what is the final conclusion? In Sergeyev's rule or beta elimination or dehydrohalogenation, what is the major product? More substituted alkene is the major product. More substituted alkene means what? The double bonded carbons containing more number of alkyl groups attached is called more substituted alkene. Suppose even if you take 2-bromobutane also, you take 2-bromobutane. There are two possibilities. This HBr can be eliminated. This results in 2-butene. %, or this HBr can be eliminated. This gives 1-butene. %. This is major product, that is minor product. This is called Sergeyev's product. Sergeyev's product. This is called Hoffman's product. Write a note. The reason for more substituted alkene as the major product the reason for more substituted alkene as the major product is due to its thermodynamic stability. Is its thermodynamic stability. The reason for more substituted alkene as the major product is its thermodynamic stability, number one. And number two, the intermediate will have less energy of activation. Write a note. If a bulky base is used, or the alkane is the alkyl halide is more sterically hindered Hoffman product is the major product. If a bulky base is used, or if the alkyl halide is sterically hindered, which is the major product? Hoffman product, that is less substituted alkene, is the major product. So now in this, except the last one, dehydration, A, B, C are correct. Dehydration means removal of water. That is not happening here. The mixture which shows positive deviation from Raoult's law, we discussed already. Yes? Ethanol plus acetone. Actually, acetone and chloroform over what we have given? Chloroform and acetone. Negative deviation, correct. Chloroethane and bromoethane, ideal solution. Fourth option, ideal. Second option also ideal. Benzene plus toluene. So in the option itself you write, first one is positive, second one is ideal, third one is negative, fourth one is again ideal solution. 116th question. It is spectrochemical series, memory recall base, spectrochemical series based on the magnitude of delta, which is called crystal field splitting energy, based on the magnitude of delta. I minus is less than Br minus is less than S2 minus SCN minus Cl minus, NO3 minus, F minus, less than OH minus, less than C2O4 2 minus, less than H2O, less than NCS, less than CH3CN, less than pyridine, less than ammonia, less than ethylene diamine, bipyridyl, less than NON, okay, NO2 minus, PPH3, CN minus, strong ligands which cause maximum delta, that is crystal field splitting energy, or ammonia, ethylene diamine, bipyridyl, NO2 minus, PPH3, Cl minus, CO. Weak ligands which cause less value of delta, or the initial ones, I minus, Br minus, S2 minus, Cl minus, F minus, C2O4 2 minus, H2O also weak ligand. So this is also memory based. Actually, this huge order, we need not mug up. At least some strong ligands, some weak ligands, you should have an idea. So 117th also, based on memory recall, which of the following is a basic amino acid? Lysine. Next one we discussed already in the class. Purification of sodium chloride from seawater. Seawater contains sodium chloride with impurities. That's how we take a saturated solution of sodium chloride seawater and pass HCl gas into it. So HCl contains Cl minus. The seawater sodium chloride also contains Cl minus. Due to common ion effect, its ionic product will be greater than solubility product. Then precipitation occurs. So the answer NaCl, right there, here, there itself. The principle is used in the purification of, the principle is used in the purification of sodium chloride by using the principle of common ion effect. Cl minus is common in both HCl and NaCl, and the ionic product exceeds the solubility product. And the ionic product exceeds the solubility product. Next question is out of syllabus. Next one, 120th question. Answer is here. CO is the strongest ligand. That's why it forms a very stable complex with hemoglobin, carboxyhemoglobin, that causes death. Those people who inhale carbon monoxide, death occurs immediately because CO is such a strong ligand. It says oxygen, which is linking to the iron 2 plus of hemoglobin. It replaces the oxygen and CO will occupy that place. So the wrong statement is carboxyhemoglobin is less stable than oxyhemoglobin is wrong. Why it is wrong? Because CO is a stronger ligand than O2. Write the reason. Because CO is a stronger ligand than O2. Now you write the hydrolysis of disaccharides. Hydrolysis of disaccharides. Sucrose, C12H22O11. When it is subjected to hydrolysis in acidic medium, you will get alpha D glucose plus beta D fructose. Now you take maltose, the same formula, C12H22O11. You will get 2 units of alpha D glucose. Now you take lactose. Same formula. So these three are called disaccharides. Disaccharides. So when it is subjected to hydrolysis, you will get here given okay alpha D galactose plus alpha D glucose. This we'll discuss again in some other question, how the 1,2, here it is 1,2 glycosidic linkage, this will check verify. Next is out of syllabus. Next is Firat 123, 124. Direct question, 71 protons, 175 minus 71. A minus Z is number of neutrons. The number given above is called A, mass number. The number given below is called Z, atomic number. A minus Z is equal to number of neutrons. So by doing all these, first option is your answer, direct question. Next is change in oxidation number of carbon, -4 to +4. Third option, direct question. Cr2 plus D4 configuration is a stronger oxidizing agent than Fe2 plus D6 configuration. So Cr3 plus, Cr2 plus. This is D4 configuration. It becomes D3 configuration. So this is whenever somebody is giving electron, it is a reducing agent. The process is called oxidation. So this oxidation potential E naught value is plus 0.44 volts. As I remember, I can write. Next, Fe2 plus with the D6 configuration. With the D5 configuration. So here E naught is equal to minus 0.77 volts. These two are oxidation potentials, not reduction potentials. Correct? Because the two processes involve loss of electron. Loss of electron is called oxidation. So in terms of SOP, standard oxidation potential, if we take 1 molar aqueous solution at 25 degrees centigrade, the potential is called standard potential. So the higher the positive value of standard oxidation potential, stronger is the reducing agent. Or higher the negative value of SRP, stronger is the reducing agent. So in terms of that, you can tell the lithium Li plus electron. What is its standard oxidation potential? Minus 3.05 volts. Sorry, plus. The reverse, Li plus electron gives Li. E naught is equal to minus, this is SRP. Since IUPAC has recommended us to use only SRP values, we are only talking about SRPs. Nowadays we are not using SOPs. But lithium is the strongest reducing agent in the periodic table. You can tell in two ways. Because of its high positive value of SOP or highest negative value of SRP. So when you compare Cr2 plus and Fe2 plus, which will have higher SOP value, that is a stronger reducing agent. So Cr2 plus is a stronger reducing agent that is giving electron. The one which gives electron is a reducing agent and undergoes oxidation. So in that way you can tell. One more way is how Cr2 plus is a better reducing agent than Fe2 plus. The Cr2 plus when loses electron and becomes Cr3 plus, its T2G shell is half filled. T2G3 Eg naught. Because it is all in aqueous medium. In aqueous medium, d orbital split. If T2G shell or T2G sublevel is half filled, it is a very stable configuration. And perhaps among different oxidation states of chromium, chromium 3 plus is the most abundant state. Means it is more stable state. That's why Cr2 plus is ready to give electron. Why Cr2 plus is ready to give electron? Because Cr3 plus is more stable. Why it is more stable? Because it T2G shell, T2G sublevel is, or T2G set of orbitals are half filled. So that is first option is correct. They are asking incorrect. Transition metals and their compounds, known for their catalytic activity, their ability to adopt multiple oxidation states, correct. Interstitial compounds are those that are formed when small atoms like hydrogen, carbon or nitrogen are trapped inside the crystal lattice of metals, correct. Direct question. The oxidation states of chromium in CrO4 2- and Cr2O7 2- are not the same, that is wrong. In both chromate and dichromate, CrO4 2- chromate, here chromium is +6, Cr2O7 2-, which is called a dichromate, also chromium is +6. So last option is wrong. Next question. Two Cl gas gives Cl2 gas. 2 moles of atoms means 2 into Avogadro number of atoms are forming 1 mole of Cl2. That is 1 mole molecules. Means Avogadro number of molecules. So when atoms convert into molecules, chemical bonds are formed. Bond formation is always exothermic. So delta H is negative. Because this is uncombined atoms are combining to form molecules. Molecule formation is always a stabilizing factor. Stability always gives energy. So delta H is negative. Now if you consider left to right, left side the number of gaseous atoms are more in number. Right side only 1 mole, Avogadro number of molecules are there. Right side Avogadro number of molecules. Left side 2 into Avogadro number of atoms. So more number of gaseous atoms, more randomness, more disorderliness, more entropy. So delta S, when delta S consider this reaction, it also decreases. So delta S is negative because the randomness is decreasing. More number of atoms are converting to less number of molecules. Delta H is also negative. Next, surface chemistry not in the syllabus. Next question. Urea reacts with water to form A, which will decompose to form B. B when passed through copper sulfate, deep blue coloration C. Actually, even if you don't know about what is this all nonsense, you directly know the answer, because with the copper sulfate, deep blue coloration is given by ammonia to form tetraammonium copper 2 sulfate. That is very, very important. We have discussed many times. So urea, when reacts with water, forms ammonium carbamate, which decomposes into ammonia, CO2, H2O. This reacts with copper sulfate to form a tetramine complex, which is deep blue. They are asking about this. Actually, next one, a little syllabus out of the book combination. Okay. CO plus H2 is called water gas or synthesis gas or blue gas. So A can be matched with third one. Synthesis gas, what are the other names? Blue gas or water gas with high calorific value. Almost the calorific value is 3600 kilocalories per meter cube. Temporary hardness of water due to the dissolved bicarbonates of calcium and magnesium. So B can be matched with 1. Diborane, next C. Diborane is an electron deficient compound. Hydrogen peroxide, non-planar structure, it has an open book structure in which the book is opened at an angle of 90 degrees called a dihedral angle, and the OH bond will make an angle of 101.5 degrees with the OO bond. Next one, carbon monoxide is neutral oxide. Barium oxide is basic, aluminum oxide is amphoteric, chlorine heptoxide is acidic. Next is ferrite. Next, for 133 you write a point. All terminal alkenes give formaldehyde as one of the ozonolysis product. All terminal alkenes give formaldehyde as one of the ozonolysis products. Like take propene. So you will get acetaldehyde plus formaldehyde. Take 1 butene. O3H2O Zn. That is the reagents required. So you will get a propanol plus methanol or formaldehyde. This is 1 butene. You take any terminal alkene like 1,3-butadiene. (1,3-butadiene). You will get 2 moles of formaldehyde plus 1 mole of glyoxal. Dr. Tony, Glyoxal just now we discussed under what heading? Intramolecular Cannizzaro reaction. Yes or no? Or you take styrene. Vinyl benzene is called styrene. CH double bond CH. This is called styrene. So you'll get benzaldehyde plus formaldehyde. So what is the hint here? Any terminal alkene give formaldehyde as one of the ozonolysis products. Next, 134. Which of the following alkane cannot be made in good yield by Wurtz reaction? Okay. So when Wurtz reaction comes as one of the methods of preparation, we can discuss all the methods of preparation of alkane. Number 1, reduction of alkyl halides. Alkyl halides. Alkyl halide is RX. If you write 2H, it becomes RH plus HX. You will get alkane. For this you can use zinc plus HCl or zinc plus acetic acid. Second method, Wurtz reaction. Actually, Wurtz reaction is a coupling reaction. Here also, we take alkyl halide, couples with another molecule of alkyl halide, dry ether solvent. You will get RR plus 2NaX. This RR is alkane. Now the point question related to this, write a note. In Wurtz reaction, alkanes with odd number of carbon atoms in Wurtz reaction, alkanes with odd number of carbon atoms are not preferred because it requires mixing of different alkyl halides. Mixing of different alkyl halides which react in different ways. Which react in different ways to form a mixture of alkanes. To form a mixture of alkanes. Now in this question, what alkane I have to prepare? Please refer to the question. Heptane, I think. Correct? C7H16. This I have to prepare. 7 carbons I require. Means I will combine C3H7Br plus C4H9Br plus add some sodium. My interest is this C3H7Br plus 2 sodium plus C4H9Br. These will react, which will be removed. 2NaBr will be removed. Ultimately, what I am going to get? C7H16. Heptane I want to make. On paper it looks very nice. This and this will combine, couple. It is a coupling reaction. Who are going to couple? The C3 part, C4 part couples, resulting C7 part. That is ideal. The problem here, when you add all these things in one single test tube, just heat it, 2 moles of this will react. So 2 C3H7Br will combine with 2 sodiums, forming C6H14. One more extra product. Or 2 moles of this also react. 2 C4H9Br plus 2 Na, C8H18. C8H18, an octane will be prepared. So how many products you are getting? 1, 2, 3. Whenever I want to prepare an alkane with odd number of carbon atoms, what I have to mix? What I have to mix? Different alkyl halides. They react in different ways, forming a mixture of alkanes. I will give one more example. Shall I give one more example after the break? Or now itself? Decide fast. No? Now in another test tube, I want to make C5H12. What is C5H12? Pentane. So 5 carbon alkane I want to prepare, which is an odd number. For which what I will do? I will add C3H7Br, C2H5Br. What are my starting materials? C3H7Br, C2H5Br, plus some sodium. plus some dry ether and a heat. Now what are the possible reactions? If these two combine, if C3H7 and C2H5, you will get pentane. If two C3H7s combine, hexane. If two C2H5s combine, butane. Instead of one alkane, how many alkanes I am getting? 3. So whenever if you take a different mixture of alkyl halides, you will get a different alkanes. So that's why alkane with odd number of carbon atoms cannot be prepared by Wurtz reaction, because that alkane mixture is very difficult to separate. But how many arrows are left? 3, 4, 5, 6, 7. That will complete after the break. Okay, the next one is Franklin reaction. This is also like Wurtz reaction. Only sodium metal is replaced by zinc. So Rx plus Zn plus Rx gives RR, alkane, plus ZnX2. Ether is the solvent. Now fourth one, decarboxylation. Decarboxylation of sodium salts of carboxylic acids. So in the decarboxylation, RCOONA, we use NaOH in the presence of CaO. You will get Na2CO3 eliminated minus Na2CO3. You will left with R here, H here. It become RH, alkane. For this I can write an example. CH3COONA. sodium acetate plus NaOH, CaO. This mixture of NaOH and CaO is called a soda lime. What it is? Soda lime. Heat, Na2CO3 you have to eliminate. Now that CH3 and H combine, forming CH4. This is decarboxylation of sodium salts of carboxylic acids. Now the fifth method, coal-based electrolysis. So in coal-based electrolysis also, we take sodium salt of carboxylic acid dissolved in water and do electrolysis. Actually, yesterday we have given a table showing electrolyte, anodic product, cathodic product. You can add this one also. So this electrolysis, 2 moles will participate. The 2 CH3s become C2H6 plus 2 CO2. This is liberated at anode. 2 NaOH plus H2 at cathode. So sodium acetate on electrolysis, aqueous solution of sodium acetate, not direct sodium acetate, aqueous solution of sodium acetate on electrolysis give ethane and carbon dioxide at anode. Suppose one student has taken this, I am erasing to get some space. Okay. Now I have taken sodium propionate, CH2COO Na plus H2O, electrolysis. What you have to do? 2 moles will participate in coal-based electrolysis. This part, 2 into this part. What is this part I underline? C2H5 part. 2 C2H5s become C4H10. This 2 CO2, because it is multiplied with 2, 2 CO2. So this will liberate it at anode. Cathodic product is same. What is cathodic product? NaOH plus H2. This is at cathode. Now sixth method, hydrolysis. Hydrolysis of Grignard reagent. Hydrolysis of Grignard reagent. This is sixth method. What is Grignard reagent? So I take RMgx R minus mgx plus. When you do hydrolysis, the bond will break, H plus OH minus. It will give RH, which is alkane, plus mgx OH. Now if this is CH3MgBr, methyl magnesium bromide, on hydrolysis, H plus OH minus. This is CH3 minus MgBr plus. So what is the left part, right part? CH4 plus MgBr OH. Suppose we take ethyl magnesium iodide. Do hydrolysis. Oh, sorry. Bond is should be broken between this part. H plus OH minus. So this will give ethane plus MgIOH. Phenyl magnesium bromide. Phenyl magnesium bromide. H plus OH minus. So we'll get benzene. So this is all about hydrolysis of Grignard reagent. That is in which number? Sixth number. Sixth. Now we go for seventh. Ready? Seventh one. Sabatier Senderens reduction. So in this, yenes means alkenes and ines are converted into yenes by hydrogen in the presence of palladium or nickel. Now you take any ene, a double bonded compound, ethene. Add hydrogen in the presence of nickel catalyst and heat. You will get ethane. Ethene to ethane. A weak pi bond breaks, two strong sigma bonds are formed. So some bond breaking energy, bond making energy. Which bond breaks? Pi bond breaks. Two sigma bonds are newly formed. So bond formation is always exothermic. So energy is released, energy is released. Here energy is absorbed. So energy is absorbed here. Energy is released here. So overall delta H is negative, which is called enthalpy of hydrogenation or heat of hydrogenation. Now you take any triple bonded compound like ethyne or acetylene. Two pi bonds must be broken here. So that's why I wrote 2H2 in the presence of nickel catalyst. So both pi bonds are broken. You will get ethane. Again here for breaking two pi bonds, energy is absorbed. How many times energy is released here? 4 times, because 4 sigma bonds are formed. Our overall net energy is released. Overall net energy is absorbed. Again delta H is negative. Exothermic, heat of hydrogenation. Mr. Dr. Ricky, yesterday we have taken 2 butane and reduced with hydrogen in the presence of palladium barium sulfate. What you got? Cis alkene. That is controlled hydrogenation or partial reduction. Same 2 butane, if you treat with sodium in liquid ammonia, you will get a trans alkene. There, yesterday what you have studied is alkyne to alkene. Here alkyne to alkane. This is complete hydrogenation. Yesterday what we discussed, I into ene is partial hydrogenation. There we are using a catalytic poison. So catalyst only functions minimum. If catalyst fully functions, you will get alkane. The catalytic poison is barium sulfate. So this is Sabatier-Senderon's reduction. 7th is over. Now, 8th one. Clemmensen reduction. In Clemmensen reduction, aldehyde group is reduced to methylene group. Or C double bond O is reduced to CH2 group. So in Clemmensen reduction, what is C double bond O called? Keto group. What is CHO called? Aldehyde group. Both are reduced to same methylene group. So here I am taking acetaldehyde. I take with zinc amalgam in concentrated HCl. This is in Clemmensen reduction. Total 4 hydrogens are involved in the reduction process. So CH3, CH, this group is reduced to what? CH2. I am rounding off because that group is reduced to CH2 group. The oxygen will be removed as water. So finally you get C2H6, ethane. Or if you take acetone, propanone, zinc amalgam, concentrated HCl. This group is reduced to what? C double bond O group is reduced to CH2 group plus water. You will get propane. This is Clemmensen reduction in which aldehydes and ketones are converted into alkanes. This is very basic. These basics should be very strong. Because in one matching type, Clemmensen reduction they will give one type, one side. Other side they give alkane. So aldehydes and ketones are reduced to alkanes. Now the ninth one, Wolff-Kishner reduction. Wolff-Kishner reduction. In Wolff-Kishner reduction, first aldehydes or ketones are treated with hydrazine. When they are treated with hydrazine, you will get hydrazone. Minus H2. This is called hydrazone. Now this hydrazone is heated with KOH in a glycol solvent. Solvent is glycol, a high boiling solvent. Simply this N2 will go away. Then it becomes RCH3, which is alkane. If you want to understand it in a better way, now I replace R with CH3 group. Then the aldehyde is acetaldehyde or IUPAC ethanol. Ethanol. Now this ethanol is converted into ethane. Ethanol to ethane by Wolff-Kishner reduction. Or if you take acetone, propanone. Here also same principle. First it is treated with hydrazine. A water molecule is eliminated. You will get hydrazone. Acetone, hydrazone. Earlier you got acetaldehyde hydrazone. It is ketone hydrazone minus water. What is the next step? Heating with KOH in glycol solvent. This is ethylene glycol. 2 OH groups. So what will be eliminated? N2 will be eliminated. Then it becomes CH3, CH2 and CH3. Propane. This very long back I discussed one more point here to call back at this juncture. In the diagonal relationship between beryllium and aluminium, long ago, if you take beryllium carbide or aluminum carbide and do hydrolysis, you will get methane. They are called as methanides. So Be2C plus H2O, 2BeO plus CH4, Al4C3 plus H2O, 4AlOH thrice, 3CH4, 12H2O. So both beryllium carbide and aluminum carbide on hydrolysis give methane. That's why they are called methanides. It is there in your notes. So these are all alkane preparation methods. For a particular question we completed all the alkane methods of preparation. So more methods are there. Reduction of alkyl halides, Wurtz reaction, Franklin reaction, decarboxylation of sodium salt of carboxylic acids, coal-based electrolysis, hydrolysis of Grignard reagent, Sabatier-Sanders reduction, Clemenson reduction, Wolff-Kishner reduction. So many methods are there for preparing alkanes. So students should know at least the side headings. Okay, alkyl halides and reduction give alkanes. I used zinc and HCl as reducing agent. You can use zinc acetic acid, zinc copper couple. NCERT textbook has given all these. Zinc copper in methyl alcohol is also a reducing agent.